Hi guys, this is the last section that goes into inverses. So I'm going to skip over this slide with the form up and jump into solving equations. Now we actually did some of this a couple of units ago. We just didn't know the restrictions on the inverses at that point in time. Now I will say this, if you ever encounter a problem where it tells you to solve an equation back like we did in trig functions, I think it was, okay, and it gives you, oh, this is a great page. It tells you to solve this, okay, but it wants the answers between 0 and 2 pi, then you wouldn't have to worry at all about the range restrictions on sine inverse and cosine inverse. I know that's tan, but you get the idea if it were sine or cosine. Like, for example, if I had sine theta equals 1/2 and I had these directions, you would answer this like you did in the past. You'd say, okay, I technically would do sine inverse of each side, but you want to know when sine comes out to 1/2, you would go through and say, okay, it's a 30-degree reference angle, some form of pi over 6. Sine is a positive in the first and second quadrant, so you would say it's 1 pi over 6 and 5 pi over 6. So if you ever see 0 to 2 pi like that, you're going to answer it like we always have. But now, if we are not given those restrictions, okay, then we need to pay attention to the restrictions on the inverses. Okay? So this first one, I have sine x plus 1. So let's first move that 1 over. Okay, now technically you're going to do sine inverse of both sides. So sine inverse of -1. So when you see that, you should think unit circle, sine is y over r. So when you come over to your unit circle, where y is -1 would be at 3 pi over 2. Now, that is not within the restrictions for sine inverse. So you don't want to do 3 pi over 2. Okay, you want to go negative pi over 2 to get to that point. Okay, let's take a look at this one. I'm going to add the 3, divide by 4. Now, let's square root both sides. When you introduce a square root here, you need the plus or minus, and it'd be root 3 over, well, the square root of 4 is just 2. So we actually have two different answers here. We want the positive root 3 over 2, so cosine inverse of the positive root 3 over 2, and cosine inverse of the negative root 3 over 2. Okay, so let's come over here. Cosine's adjacent over hypotenuse, so it's a 30-degree reference angle, but remember that we want our answers in radians. So 30 degrees means a denominator of 6. Now, for the positive, the restrictions for sine are the first two quadrants. So this would just be a 1 pi over 6. For the negative, we will want the quadrant 2 answer, which would be 5 pi over. All right, this should say equals 0, sorry. So this one, when you look at it, notice that you have a trig function, squared, linear, and then just a constant. So this we're going to want to factor. Okay, so set up your parentheses. And when we had done these before, when we were like in person class, I had said if it helps you to do 12x squared minus 1x minus 1 to factor it, you can do that way and then swap out the x's for cosine x. So if you think about it, you know you're going to have a cosine x here and here. I'll figure out the numbers that go in front of them in a second. Well, the only factors of 1 are 1 and 1. And for your signs to be negative here, we know we need one of each sign. Okay, so now I'm going to go back to the 12 part just because that's the hardest part of it in my mind. So we somehow need to multiply to a 12. So we could have 12 and 1, 4 and 3, 6 and 2. Okay? But we also need this middle to sum to a -1. So if we do 6 and 2, that's not going to get to a -1 in the middle. If we do 12 and 1, that's not going to work. But 4 and 3 are close enough that that could work out. Now we want it to be a -1, so let's do the 4 here and the 3 here. So let's check ourselves. 12x squared minus 4 cosine x plus 3 cosine x. That will get us the -1 and then -1. So now we need to set each piece equal to 0. So this would get cosine x equals -1/4. So we're doing cosine inverse of -1/4. And this one you would get cosine x equals 1/3. So you want to do cosine inverse of 1/3. Now, when you look at that, you're like, wait, they're not from my special right triangles. This would be a calculator problem. Okay, so you could literally punch in your calculator and you would get approximately 1.823 and 1.231. And maybe just enter that to make sure you're entering it okay into your calculator that you get those two answers. Okay, let's do a couple more. So this is another factoring one. You see a trig function, squared, linear, and a constant. So let's see what happens in this one. So we need a sine here and here. Factors are 1 and 1. Like I said, I'm going to do the 12 part last because that takes the most time. Now, if you have a negative here and a positive here, that means these were both negatives. So once again, it's actually 12. So 12 and 1 can't get us to the negative 7. 6 and 2 won't either. So, 4 and 3. So when I solve this, I'm going to skip a couple steps here. I'm going to add 1, divide by 4, sine inverse both sides. So sine inverse of 1/4, sine inverse of 1/3. So, these, once again, aren't ratios from your special right triangle, so you would enter those in the calculator and you'd get 0.253 and 0.340. Once again, just make sure you're able to enter those correctly. Maybe try and just make sure you get those values. All right, one like this. So when you look at this, do not divide cosine x out from both sides. You're going to lose a potential answer. So let's subtract the cosine over so we get it equal to 0. Now you have a GCF of cosine, so let's factor that out. Set each piece equal to 0. Excuse me. So here I'm going to do cosine inverse of 0, and here cosine inverse of 1. Okay, so those are both from my unit circle. So, sorry. Okay, so cosine is x over r, where r is always 1. So we need to find where is x 0. So within the restrictions for cosine, which are 0 to pi, it would be right here at pi over 2. Where is it 1? Right here, which would just be 0. Okay. I'm probably going to do I'm going to skip 4. I'm just going to do 3 and 5. Okay, so once again, you have a trig function squared, linear, and you have a constant, but let's get that constant over so that this is equals to 0. So this is one where we're going to factor. So we have a sign here and here. Now, factors of 3 are 3 and 1. Now, we have to be a little more careful here because we need to figure out our signs, but we also need to figure out what goes here. Is it 1 and 4? Is it 2 and 2? Okay. And we need to sum to a negative 4 in the middle. So I'm going to try 2 and 2, because that would get me the 4 sine squared. That would give me a 6 and a 2, which could sum to a 4. But for it to be a negative 4, let's do a negative 6 and a positive 2. All right. So set each one equal to 0. Do sine inverse of each side. Now you need to be able to recognize which ones are special. So negative 1/2 is from a special right triangle. So 1/2 for sine would be 30 degrees, so some form of pi over 6. So I'm going to use this space down here. Now, I want it negative. So remember, the restrictions for sine are in these two quadrants. So to get down to this quadrant, it would normally be 11 pi over 6, but that's not in our restrictions for sine, so it would be negative pi over 6. Now, this one, you should recognize, this is too big. It's outside of the negative 1 to 1. That has no solution. Okay. This last one. Now, you don't have a trig function squared, so we're not doing the whole factoring idea. Let's just divide the 2 over. Sine inverse each side. This is from our 45, 45, 90, so it is simply pi over 4. Okay, I have a review file for you guys to go through. The quiz, quest, whatever you want to call it, will be pushed out later tonight. I will have optional Zoom office hours Friday morning in case anybody needs help with this stuff. They're a little stuck. They have questions on the quest, anything like that. Please reach out at any time if you have any questions.